So good morning, everyone. We're here meeting and with part of the crowd that attended the Enchanted Universe conference at Pari in September this year. And we're here today to discuss with Jonathan Allday about quantum physics. And so the structure of this conversation is going to be me asking a few questions to Jonathan, also on the occasion of the publishing of the second edition of his book Quantum Reality, and then we will open it up for discussion, questions, answers from the rest of us. So let's get into it. So thank you so much, Jonathan, for doing this. And there's so much to unpack, especially when talking about quantum mechanics. I want to start with entanglement. So what can you say about this year's Nobel Prize in Physics in terms of, and I know, again, it's a huge question, in terms of its relevance, the justice made, and a little bit the history of both, let's call it the problem of entanglement, its theoretical articulation, and also these experimental tests, and a little bit about the future of it. So you see a very simple question to format.
Schrodinger's dog has just walked in.
Yeah.
I was really excited to see the winners of the Nobel Prize, partly because I've been writing about all of them in the second edition of the book. And so that was quite a nice thing to see that sort of manifest itself. I can't help feeling, though, it's tinged with a slight degree of sadness in that I think John Bell would have been for sure in the mix to get the Nobel Prize if he would still been with us. And I suppose an argument could be made for David Bohm as well, because he was the one that kind of pushed Bell on the track that eventually led to, in essence, the Nobel Prize that we have right now. I've been trying to think about a simple-ish way of trying to make clear what entanglement is all about. And I've kind of come up with this, if this helps. If you've got some business going on over here, and there's some other business going on over there, which is in some sense correlated, and yet there's no way that these two things can be linked together in the explicate layer, but there is a linkage in the quantum or the implicate layer, then that's kind of entanglement. It's when we make measurements over here in a system and we find that they are correlated to measurements we make over here in another system. But when we search for some explicate way in which they are linked, we can't find one. In fact, we deliberately set up our experiments to exclude there being some connection between them at the explicate layer. And what John Bell did, developing work by Einstein, Podolsky, and Rosen, and then David Bohm couched it in a slightly different way. What John Bell did was say, okay, if we have these correlations, these influences apparently between these two businesses or measurements going on here and there, what is the extent to which they can be correlated within a classical theory? In other words, if there were some variables that we don't yet know about, which are actually influencing both systems, to what extent can they influence those two systems? And it kind of put an upper bound on what was possible in the in the sort of hidden variable correlations, as it were. And then Clauser was the first person to actually make a measurement along with his team about the relationships between these two. And then Aspect came along and did a better experiment because the technology had developed. And in every instance, quantum theory violates this upper bound put on it by Bell.
Let me just ask you to pause here and maybe explicate a bit more what's meant by classical here. You mean realism? You mean locality? Because I always feel there's some big concepts to trade here for, right?
Yeah.
So yeah. Could you articulate that for us, please?
Well, I guess if I was doing that, I'd think about one of the big difference between what we call classical physics. And I think almost every different physicist has a slightly different version of what they mean by classical physics. So let's say date range, you know, before the 1920s, how did we do physics? And then quantum theory came in the 1920s. In classical physics, systems can behave in slightly different ways. Imagine you've got, this is one of my favorite analogies. I hope it works for you guys too. Imagine we've got a spring held at one end with a mass on the other. Simple thing you do every day in a school lab. You pull the spring down and let it go, and it bounces up and down. You pull the ring slightly to one side and let it go, and it swings backwards and forwards. Now, if you sort of pull it down and pull it to the side, then you get a very complicated dance, which is a combination of those bouncy, bouncy and swingy, swingy movements. Mm-hmm. And that's what we mean when we combine systems classically, or rather combine motions of systems classically. Now, at the quantum or the implicate layer, when you combine things like that, it's very, very different. If you combine the states of a system at the quantum layer, and then you take a measurement, you find the system collapses into either the bouncy, bouncy or the swingy, swingy. You never get that combination of the two. And so that's the difference between at the quantum level, you can combine system states, but in a way you never see at the classical level. In fact, these combinations that you can get at the quantum level are classically impossible. You get these combinations that really don't work classically. And then if you entangle two springs, and I'm using the spring metaphorically here, you have two springs that interact with one another, and then they separate, then you find, if the combination is made at the quantum level, if you measure this spring to be bouncing, then that spring over there must be swinging. And if you measure this one to be swinging, then that one must be bouncing. They are linked with one another, entangled with one another at the implicate layer. Does that go anywhere to answer your question?
Yes, let's go a bit deeper into this because it's hard. So you're talking about these combinations, and they sound to me like they belong to a realm of possibilities.
Yes.
But I think what's really amazing about quantum physics, and please correct me and elaborate on that, is that this realm of the virtual or the possible, in a very strange manner, leaks in the realm of the actual. Right?
Yes.
Because we could be talking about those possibilities, and mathematically, physicists know how to express them. But the really shocking thing is that those leak into the actual world. And in a way, maybe later or now, we can talk about that compressed summary that came up during the meeting in Pari, that the imaginary is real, right? So yeah. How does that have to do with entanglement and also with the empirical demonstration of entanglement?
Well, it has to do with entanglement because, as you say, this quantum realm, and you put your finger on one of the crucial problems to do with quantum theory. You know, Chris Isham, I think it was, said there were 4 related problems with quantum theory: measurement problem, entanglement, what a state means, and I can't remember the 4th because it's obviously too hard, but I can look it up. It's in the book. Anyway, when two systems interact with one another, the whole thing about entanglement is, as you've just said, in the realm of possibility, the possibilities for the two systems become linked. So that if one system, the possibility is made actual, that forces in the other system its corresponding possibility to be made actual as well. Even though we may not have measured this system, we know exactly what it's going to be because we've measured that system. And the problem is, if these two measurements are separated by large distances so that they can't communicate with each other, then you have this problem. How do you explain that connection at a classical or explicate layer? So yeah, I mean, and this is one of the problems of interpretation, and one of the radical solutions, as you know, the many worlds interpretation suggests that actually all the different possibilities that are mapped out in the quantum layer are actually all happening at the same time, but in different universes. And I think this is a rather different thing to Bernard's metaverse, it's a slightly, the word multiple universes is used in many different ways within physics, and they all get mapped into science fiction in rather different ways as well. But it is one of the key issues that we don't understand is how can these possibilities actually become manifest in the real world? And the Copenhagen interpretation, this sort of classical standard interpretation that most physicists, if they can be bothered to say what they think at all, would actually say that's it. The people like Heisenberg and Bohr kind of said there's just a line you have to draw, and you draw the line at some particularly relevant point, and above here we're working classically, and below that. And many people find that very unsatisfactory, particularly since one of the things that Anton Zeilinger has done in his brilliant array of work that he's done, his team has done, is it's this wave particle duality thing, which again is all part of this layer of possibilities. It's well rehearsed now. We know about these experiments where you can fire electrons at double slits and see their wave-like nature. But he's done it for buckyballs, you know, carbon-60 molecules. I think in the latest version of the book, I've actually taken a report on his latest experiment where he's dealing with molecules with thousands of atoms in them. And those are getting to be very, very large objects. I would say embarrassingly large objects to still be showing quantum properties like wave particle duality, or basically showing interference effects at that level. Then where do you start to put this cut? It makes it ever more mysterious. At what point, at what scale does the possibilities layer become actualized?
A moment ago, you mentioned one interpretation, and a few minutes ago, you were, it seemed to me, equating what you call the quantum layer with the implicate layer, which in a way perhaps betrays already some choice of interpretation and even some ontological commitments as to what is going on. So tell us a bit more about this implicate layer and to what extent this is congruent or mapped with other ways of interpreting what quantum physics is about.
Well, I just find it a very helpful terminology. And as everybody knows, David Bohm introduced this terminology, and I just find it a very handy shortcut to express whatever might be going on in the underlying quantum business. That takes place in an implicate layer, which then, as you say, leaks into the world that we see around us, which is an explicate layer. If you're asking me to put my finger down and say exactly where I stand ontologically, then I've come to believe that the wave function, this thing that expresses, or the amplitudes, if you like that terminology better, this thing that expresses all the different possibilities of quantum systems, is actually ontologically a real thing. But we have to extend our definition of what we mean by real in order to accommodate that. And so I believe that there is an underlying objective possibility layer, if I can phrase it that way, which quantum theory points towards, and to some extent describes, although I think it probably goes much deeper than that. That doesn't solve the problem of how this underlying possibilities become manifest. It just gives us a terminology to work with. Now, some people think that the wave function and these possibilities are simply ways of expressing our own knowledge about the system. So there's no ontological reality there. They just sort of shut up and calculate. The wave function is just a mathematical tool to connect this prediction to that prediction.
Could you strawman that position? You know what I mean?
Well, I could in the sense that,
because I'm saying we often in a loving way like to caricaturize it with shut up and calculate, which by the way can be as literal as it gets, shut up and calculate. But what's their point? What's their strong point about that?
Well, the strong point about it is that you can actually do research. You know, there's a nice little story which I think was told by Steven Weinberg, that he met a fellow physicist in an elevator, and they were asking what had happened to this graduate student who'd had a very promising career. And his colleague sort of sadly shook his head and said, they tried to understand quantum theory.
Yeah.
You know, and that sort of put a death knell on any further research that this poor person could have. So, you know, physics is, Bernard knows far better than me, you know, it is a profession these days, certainly at the academic layer, and you have to produce papers and you have to develop tenure, et cetera, et cetera. And so stopping and worrying about the intangible and possibly even at this point insoluble problems of what quantum theory actually means, you can actually get on and make progress, and dramatic and spectacular progress has been made. But still, again, there are people like David Bohm and John Bell and others who are just not that satisfied with that. They really want to know what's going on at the underlying layer. What does this tell us? And my fundamental point is the quantum theory works too well. It is spectacularly successful as a way of describing the world. And to imagine that we could just somehow, out of our imaginations, conjure up something like the wave function, and then it works so very, very well to describe experiments without it having some link to something that's ontologically out there. I just don't think we're that good at inventing games. Does that make sense?
Yes.
You kind of hesitated there as if you really wanted to say, no, it didn't.
Well, no, I mean, I'm all for avoiding those boxes of saying that's science, that's philosophy, that's this, that's that. It's all interconnected. So to decide I won't go further can be a very strategic decision, as you say, well, I need to get some calculations done, but I wish we could switch then to other modes of thinking and entertain those, because these mysteries are great gifts to humanity in a way, maybe material gifts to humanity.
Also, we all kind of became scientists because we wanted to find out what was going on. And it seems to sort of surrender that fundamental reason why you got into it in the first place at the last.
Now we can come back to, and we will, to the actual kind of more concrete difficult questions about the physics, but I wanted now to shift gears a bit and ask you about how far can we stretch the analogy, and I'll say analogy, and I'll see if it can be made an homology or maybe literally, from the entanglement of, can I say, material substances or processes to those of mental processes. How much, you know, because on the one hand we have the shut up and calculate, and on the other hand, we have the other extreme, which they meet in a way, which is the new age way of conceiving quantum stuff, which is like, sure, I mean, it's all the same. But is there a third way that transcends those extreme positions, where we could start to conceive that entanglement is something that happens to our own psyches in a way? Is this a really odd question to ask a proper physicist like you?
Well, firstly, I don't think I'm necessarily a proper physicist, but it's a very interesting question, because actually, in many ways, that's exactly why I wrote the book. And I know you weren't sort of doing that. Well, if you did that deliberate segue to let me open up into that, then that was a brilliantly couched one. But I became very conscious that there's a lot of quantum hype out there. I mean, if you Google quantum, you get a whole range of different books, quantum healing crystals through to what have you. And you know, certainly quantum theory has shaken up our very notions of what real is and how we go about exploring the world. And it can be very useful to provide metaphors for something else. But the whole purpose of my book was to try and explain how quantum theory actually worked in practice, so that people could judge for themselves what was quantum hype and what was actually reasonable speculation. So I don't think there's any obvious direct line you can draw between having two particles entangled and correlations between measurements that you can't explain classically, and then jumping to straight in and then say, oh, well, things like telepathy and everything else, you know, must therefore follow. I like what Eddington once said, which was the quantum theory sort of loosened up things. He said there was a traffic light there was a train signal that was set to red, which has now been set to green. You know, it's not that quantum theory allows us to explain all of these things necessarily. It's that quantum theory puts us closer to a world in which these things are possible. You can't use it as an excuse or a backup, but what you can do is say, look, when we were in the classical realm, we were too ready to dismiss ourselves as automata, and no such thing as consciousness existed, and we all were we had no free will and everything like that, because we were doing our work in a Newtonian regime when it looked like that. We should have held to our internal senses that we have free will, etc. And what quantum theory has done is kind of said, well, look, you were a bit too quick to judge, weren't you? Look what physics is doing now. Yeah. And I think that's the real gift of quantum theory. I don't see that it puts us in a scenario where we can explain mentality or anything like that directly from quantum theory, but it does mean that we're in a world which is closer to being one, in which we can imagine these things happen.
Thank you for that image. I didn't know about this, of the traffic light, and it's very interesting and also ironical, or even it's ironical in the sense that physicists discovering that the virtual, again, is a province of the real, not just the actual, opens the door now to at least conceive that the mind can also inhabit that virtual space, not just the actual. And well, research needs to be done, but the stop or the dead end street sign has been removed, or the traffic light.
But I do think if we push that analogy slightly further, if I may, there's a whole queue of biologists standing stationary at the stop sign because they haven't noticed that it's gone green, or either the biological version of it hasn't gone green yet. It's still on stop. And there are some well-known biologists we could mention in polite company if we wanted to, that are absolutely stood still there at the stop sign.
Yeah. Let me jump to a related question, which again, no hope of possibly covering it, but maybe you can scratch it or pet it a bit. So I get the so-called role of the observer, right? So much confusion. So what does that really mean? Because it seems to call or summon at least a human mind observing it, whatever's going on. So
personally, I think that's a bit overblown myself. I don't think, certainly people have proposed, and von Neumann actually didn't propose this explicitly or explicitly in his book, but a lot of people think it was under the sort of in there, reading between the lines. And Bauer and London, I think it was, who actually did put it into a paper for the first time, that when you measure a system, if you have a quantum system, you make a measurement of it, and that thing that you use to make the measurement is described in a quantum way, then the interaction between the two entangles them. And then something else comes along and measures that gets entangled, and then it gets entangled. Where does it actually stop? At what point does the actual entanglement stop and the possibility become actualized out of the probability? And because you can't obviously find something, you sort of keep going until you jump to the sort of the mind of an observer, and you say, okay, well, that's what's doing it. As soon as this registration of this measurement event enters the mind of an observer, that's when the entanglement collapses. And it's kind of pushing it along until you find something that physics can't explain, the mind, and you stop there and say, okay, that's what did it. And that seems to me to be unsatisfactory, because certainly we know the universe has been around for billions of years before we were here as conscious observers. So who was collapsing the measurements before then? Well, you can bring a panpsychism in, or a deity in, throwing dice or not. But again, it seems to me to be trying to go for a cheap's the wrong phrase, an easy answer. I used to think that astrophysicists, forgive me on this, Bernard, whenever they saw something they couldn't explain in the sky, oh, it's a black hole. Oh, it's a black hole. Oh, it's a black hole. And that way you'd made three things you didn't understand, just one thing you didn't understand. And I kind of feel that the sort of using the mind is the same idea. I think it's to do with complex systems. Something happens when a quantum system interacts with something that's sufficiently large or sufficiently complicated, and that causes, in some way we really don't understand, the state to collapse out of its possibilities and become actualized. I mean, Roger Penrose is working on the notion that gravity is all tied in with this, and I think that's an interesting avenue to pursue.
You mentioned the measurement problem as one of the four main problems. So it's
whatever the fourth one was.
Yeah.
I can't remember.
Yeah, it's good to have room for another one in case it comes to mind. But in any case, you can check. Yeah, but in any case, the measurement problem is a problem / a mystery yet, in a way, because me asking you about the role of the observer brought us, of course, to, you just said, the registration of measurement in the mind of, but I like this. Well, it's not that I like it, but I think it's interesting, this evolutionary argument of, so what? Quantum systems were not collapsing before there were humans or life in this planet. But then we're back to a very fundamental question, apparently simple and trivial, which is, what is measurement then? What is measurement?
Yeah, I mean, that's one of the key things, isn't it? Because we so again, I think we use that as a phrase to dress up the fact that we don't really know what's happening. Solving the measurement problem would require some clear indication of what is a measurement. We simply use it, I think, as a label to indicate that process by which the possibilities become actualized into a single. You have this spread of possibilities, then some, it's like this, have you seen that, is it Far Side cartoon? We've got these two scientists standing in front of a blackboard and it's covered in equations. And then the bottom corner, it just says, and then a miracle happens.
Yeah.
That's kind of the measurement problem. It's a label that we use to simply mean, what is it that's turning this range of possibilities into an actuality? And we think of it because obviously in physics, we're using quantum theory to relate our measurements at one time to our measurements at another time, because that's how you do science. You make measurements, but it's broader than that. And if I can just come back to your notion of the observer, because I don't think I tidied that bit up, if you don't mind. I think this idea that perhaps the observer is what causes the entering the mind of the observer is what causes the potential to become actual. People also have used that to generate the idea of the, that we are connected to the world, where the oneness of the world. And I do think that quantum theory does tell us that there's an underlying connection in the world, but I don't think it's to do the measurement problem. I think it's to do with things at the entanglement layer and that sort of thing. So I think we are able to say that there is an underlying wholeness to the world, but I don't think this role of the observer in measurement is what tells us that.
All right. So
while you're pausing for breath.
Yeah, I'm pausing because this
carry on talking. I'm going to find
you're saying they deserve some silence. It's not easy stuff. And while you search for it, well, I'll wait because I have two more questions, and then I really want to open it up so to have time for discussion in a way that it's not rushed.
The other thing that ought to be mentioned, if we're allowing ourselves to go slightly off the deep end, that we did talk about state reduction, probability, measurement, and entanglement are Chris Isham's 4 problems that he puts in a tetrahedron. State reduction, what do we mean by probability? What do we mean by measurement? And what do we mean by entanglement? And you can't separate those out. But I think it was John Wheeler who came up with the idea that actually our observations now could retrocausally collapse the wave function in the past. So he kind of gets round this, what's been doing it up to now, by saying, well, the fact that we are here now as what's created the history of the universe up to now.
Wow.
So, you know, you can tell that we are experimentally ill-determined at this point, because all sorts of wild ideas are coming about the woodwork.
Yes. So, well, that's maybe a good segue, strange one, to ask you about what would Einstein say, what do you think Einstein would say today of the Nobel Prize on spooky action at a distance being still spooky, but more real than he wanted it to be, or that he thought it should be?
I think he might return to his original phrase, which is, I'll give up and become a watchmaker. Einstein, in many ways, I think history is coming to say that Einstein was probably one of the last of the great classical physicists, rather than, because he never fully accepted the concept of quantum theory. You know, we always made this aphorism about gambling habits of deities. And what this was trying to express was his fundamentally philosophical position, which the universe was a causal nexus, by which I mean cause, effect followed cause in a strict logical sequence, all governed by the laws of nature. And what he couldn't accept is that quantum theory appeared to introduce acausal things. A radioactive atom decays in an instant, and you can see nothing prior to that moment that would indicate that the atom's about to decay or the nucleus is about to decay. It just does it. And you ask, well, what is the physics causing it to decay? There is no physics causing it to decay. We can calculate the chance of it decaying, but we can't predict when it will decay. Einstein hated that because it was against his fundamental philosophical position. Not that Einstein, I think, was a person who made much of a division between physics and philosophy, but he approached the world as a causal nexus. So what he wanted was that there was some other layer of theory yet to be created, this hidden variable, which just means that we don't know the physics underneath it. But if we knew what these variables were and we could measure them, then we could actually predict the moment at which the nucleus would decay, for example. And it would be these hidden variables that also governed the correlation between the business over here and the business over here that I mentioned at the beginning. But what the work of these Nobel Prize winning physicists have done is it's basically said, okay, Einstein, you can have your hidden variable theory. By all means, go away and create one. Go away and create a theory that explains why these two businesses are correlated. But the only way your theory will reproduce exactly what quantum theory gets is if you throw away relativity. Your choice, man. Because what the work of these people has done is it's demonstrated, and there's some amazing experiments going on at the moment. I'll mention one of them if I may, because it's just mind-blowing. What these experiments have done is said, okay, we might be measuring this thing over here in a certain way, but we can change what we're doing over here so quickly that the information about what happened here hasn't reached there before we take the measurement. And yet the correlations still happen. And so because these correlations happen, even though we change what types of measurements we're doing too quickly for light signals technically to get between the two, it means that if Einstein's hidden variable theory was going to work, it would have to violate the special theory of relativity. Quantum theory kind of gets around this because it's happening at the implicate layer. Now, what I'm saying is this technique is what's called the spin of a particle. We can measure it along one angle here, and we can measure it on a different angle over here. And if the two particles are entangled, then these two measurements will be correlated. But how do you choose which angle you're going to measure each case? Well, they've done an experiment where they're using the light from distant galaxies or supernovae to actually determine which angle. They're using the polarization of the light or something to switch over these measurements. And these galaxies are so separated in the sky, the only connection between them must have happened billions of years ago. So if there's going to be any hidden variable that's going to determine how these correlations happen now, it must have been set billions of years ago when these two galaxies or quasars or supernovae stars, whatever they're using, were in contact with each other. And that just defies plausibility. And they're doing more and more experiments like that, which are closing loopholes and showing Einstein, you know, who must be revolving wherever he is right now, that actually the hidden variable theory, if it exists, would have to be even weirder than quantum theory.
Yeah. I like these loopholes because they, well, they're annoying in a way, but they're also windows into, into aspects of reality we haven't even imagined yet, probably. So my last reflection is, and you were already alluding to it, talking about ongoing experiments, is what do you see the future of entanglement, in the sense that, of course, given nowadays hybridization, to put it generously, between academia and the corporate world and neoliberalism and so on, you know, it's been given for the Nobel Prize has been awarded for the seminal contributions, but then the very last says, and the potential this holds for, you know, for quantum
pioneering quantum information science.
Yes,
I printed it out. Yeah.
Yes, exactly. Which is, in a way, it's really a supremacy game amongst, you know, big nations and states in the world. So leaving that aside, or you can comment on that because it's important, it's going to be consequential. What about the more theoretical aspect of entanglement? How do you see that unfolding in the near future? Is there more work to do, or is it now, quote unquote, just about, you know, building clever hacks technologically that allows to, you know, encrypt things in a different way, and the first who gets it just breaks all the codes and hurry up. Yeah.
I mean, I thought it was very interesting that that last sentence was on the citation, because it kind of, well, it's very theoretical work here, folks, but don't worry, it's got a practical application. It's in quantum computing. So, and I kind of thought that was a little bit of a cop-out. I'm going to pick up on the theoretical side, if I may, because although I think there's obviously more and more experiments that can be done to sort of demonstrate, close more and more loopholes to do with entanglement, and demonstrate entanglement over systems that are wider and wider and wider separated. I do think there's more work to be done, because we're talking all the time when we talk about entanglement, we're talking about it at the level of quantum theory. But we need to remember there is also quantum field theory. And a lot of the conversations that go on about the interpretation of quantum mechanics, a lot of the conversations that go on about the meaning of quantum mechanics are all held at the quantum mechanics level. Whereas actually, and I'm, you know, sorry, folks, if you're just getting to grips with quantum theory, there's another thing underneath that you're going to have to get to grips with, which is quantum field theory, which is where we fundamentally are actually at. What does entanglement mean at that layer? And there's some fascinating things to dig out there. I'll just drop one in, which is a bit mind-blowing. In quantum field theory, there is something called the vacuum. And the vacuum is the most maximally entangled state. You know, it's the most maximally entangled in the sense that all possibilities are on cards there. All the possibilities are in there, and they're all entangled with each other. And there's also a lovely little theorem, which I don't yet understand very much about, which is that if you, I don't want to go into quantum theory too much, quantum field theory too much, but if you apply the operators, for what's a better word, of quantum field theory over here, you can't help but create a state that has a little bit of possibility over there as well. So it's telling you you can't actually do things locally. There is non-locality in here. And that's what I meant when I said, yes, we're, you know, there's a wholeness to the universe, which includes the observer as well, but it's not to do with the measurement problem. It's to do with non-locality. So I want to understand more about entanglement at the quantum field theory level, where it seems to be built into the theory fundamentally, rather than a discovery that's happened. It's in there, it's part and parcel of the theory. And I think experiments can obviously carry on and close up more and more loopholes. And there are undoubtedly going to be greater and greater developments in quantum computing. But personally, I think quantum computing is a bit of snake oil. There's no actual, I'm aware of, theorem or proof that says a quantum computer will always, in all circumstances, be faster than a digital computer. You can write algorithms or code, if you like, specific algorithms or codes, which will run multiple times, billions of times faster on a quantum computer than on a digital one. But they're very specific algorithms, and there's no general proof that they'll always be faster. Now, the money's flooding into this because there's one thing called Shor's algorithm, which allows you essentially to crack, as you say, encryptions. Whereas in a digital realm, you'd be running the program for thousands of years to try and crack the encryption. In a quantum computer, you can crack it fast. And that's why the money is going into developing quantum computers. But I'm not sure they're going to be fast under every circumstance. So that's where the future is, theoretically, let's understand more about it at the field level. Bernard may well be able to say a few more things about this, because my understanding of this is very rudimentary at this point. And obviously, experimentally, we can develop better and better experiments that close up all these loopholes. And technologically, we're throwing vast amounts of money into quantum computing. Whether that pays back generally, worth pausing on.
Well, thank you, Jonathan. I think this is perfect time to open it up to the rest of the community here. We've had this kind of delicious tasting of some of the aspects, but as always, addressing core ideas, but barely at the surface, because it's difficult work. But I think, at least in my estimation, you brought some very important clarities to some of the aspects that weren't so clear in my mind, but still there remain big question marks, which is exciting. Yeah, thank you so much. So now I'll invite anybody. Okay, Bernard already raised a hand. So yes. So let me just, you're ready, you're unmuted. Yeah, go ahead, Bernard.
Yeah. Okay. Thank you, Jonathan and Alex. Because I'm a physicist, there's a lot I could react to, and I'm not going to do that because I think we've only got 10 minutes, and I think other people's comments will be more interesting. I just wanted to make just a few points, Jonathan. First of all, you started off with this sociological comment about what a pity it was that people like Bohm and Bell couldn't share the Nobel Prize. I mean, that is true, but that happens with every award. I mean, the same thing when Penrose got it, I thought it was a shame if Hawking had lived another year, he would have got it. Absolutely. And it's always the fact that whether you get a Nobel Prize is often just a matter of whether you live long enough. So it's, and remember, even Einstein had to wait till 1921 before he got his Nobel Prize. So he had to wait 15 years.
It's just a way of bringing those names into the conversation in some ways.
Indeed. And of course, they were both more, great physicists who deserved it. For everyone who gets a Nobel Prize, there are many others who deserved it. And if you think of the people who got the Nobel Prizes for gravitational waves, they were very lucky because they're all in their 80s. And if we waited another 10 years, the chances are they will all be dead, So, I mean, it's luck to some extent, but we shouldn't be too bothered about that. I think one of the key issues is the whole issue of consciousness. And as you say, I mean, I think for people in this group, the question of whether consciousness is collapsing the wave function or involved in quantum theory is really crucial. But you're quite right that among mainstream quantum physicists, they still try and, suppress the role of consciousness. They think there might be something purely intrinsic, to the wave function which makes it collapse. And we just don't know. I would only say that for me personally, I do think consciousness is important, and those physicists who don't want to resort to consciousness, they're just reflecting a general tendency to try and keep consciousness out of the picture, which I think one has to resist. But I also agree that it relates to complexity, because to me, consciousness is the culmination of complexity. But it's a subtle issue because, you know, for example, people often quote Penrose, and Hameroff, but they're not arguing that consciousness collapses the wave function. They're actually saying that the quantum processes, like microtubules, create consciousness, and people sometimes don't make that distinction.
Agree.
And the third point, I mean, to me, the most fascinating point, which you did refer to, and obviously didn't have time to discuss in detail, was this idea, you know, going back to Wheeler, that you can affect events billions of years in the past, which to me is so intriguing. And just in case, if I've just got 1 minute just to elaborate.
Bernard, don't rush, because we have time, and these are important points. Please take your time.
I would just elaborate on that point. I'm sure Jonathan does it in his book anyway, but you know, the whole point about the two slit experiment is that you've got two slits, and if you close one slit, it behaves like a particle. If you don't close one of the slits, if you don't know which slit it's gone through, it behaves like a wave, and that's the fundamental paradox, if you like, within quantum theory, wave-particle duality. What happens in the experiments Jonathan is referring to, I mean, they're different forms, but for example, you have a quasar. The light from the quasar is bent by a galaxy between us and the quasar. So you have two images of the quasar. Now, the point is that if you look to see which, you've got the light coming from these two images because of light bending. If you look to see which image the light has come from, it behaves like a particle. If you don't look to see which image the light comes from, you get entanglement. So essentially it behaves like a wave. So essentially it's exactly the same process as in the two slit experiment, except you're looking back billions of years into the past. And it's absolutely fascinating. It was Wheeler who first suggested that. But then you've still got the question, and that's experimentally now confirmed. But you still got the question, how do you interpret that? And you have two interpretations. One is to say you are actually affecting the past, you know, even though that seems to go against retrocausality. But the other view is simply the sort of more conventional view that there is no well-defined state until you make the observation. In other words, that's more like the Copenhagen picture. So, but I'm glad that Jonathan mentioned that, because to me that's really almost the most intriguing of all the experiments, affecting something a billion years in the past. Yeah. That's all I'll say anyway. But thank you very much indeed, Jonathan. I've not read this second book yet. I'm reading the relativity book, but I'm looking forward to it.
If I can just pick up on that point, I couldn't agree with Bernard more. My view, you know, very unqualified to express a view really, is that it's not consciousness that collapses the wave function, but once we understand the physics that brings about the collapse of the wave function, that may help us to explain consciousness. So I kind of go with the sort of Penrose line, that it's a pointer that there's some underlying physics that we don't understand going on. And maybe when you factor complexity in as well, I'm actually literally waving my hands in this hand waving explanation that it might arise from that.
Well, absolutely. And I mean, indeed, people might even remember when I gave my talk at Pari that from my perspective, you need a deeper theory which underlies both quantum theory and mentality. And that goes beyond quantum theory itself, because, you know, it's where you got the merging of relativity theory and quantum theory. Your two books, Jonathan, the merging of your two books, that's the level at which we're going to find consciousness, in my view.
Yeah, I agree, for what it's worth.
Thank you so much, Bernard, for contributing in this way. So, Alan, would you like to unmute yourself? Yes.
Yes, thank you. Well, Bernard mentioned consciousness, and I'd just like to follow on from that a little bit. And in particular, my impression is that when we talk about quantum physics, we're always talking about two layers of reality, the implicate and the explicate. And really, I'm wondering if it would be useful or revealing if we considered more than two layers. And I'd start with three layers simply because, based on my understanding of Vedic philosophy, there are three layers. And in terms of the individual, we are all apparently have a physical body a subtle body, the subtle relating to the mind, and a causal body. And, you know, in a sense of a causal body, one could think of, well, it's the causal body from which the genius is born, as it were, if one was to believe in reincarnation. But the universe as well has a physical body, a subtle body, and a causal body, going back to as above, so below. And just to sort of, without using the, well, using English words rather than Sanskrit, my understanding is the causal body essentially, and it's all powered by consciousness, but it includes the unmanifest, which is said to include a vast and infinite number of universes. And from this causal body, a particular universe comes forth, a particular creation with its own nature. That's the causal. And again, it equally applies to the individual. And we have the subtle body, which consists of, well, I'd say mind, but it's not all of mind, it's an aspect of mind, but certainly that part that results in the individual. And two other elements, space, or Sanskrit word akasha, and air. And it's just interesting. So those make up most of what we consider to be mind. I believe some of it actually exists in the causal realm. And space and time are said to be introduced with akasha. So in terms of this system, from 1 to 9, space and time come in right in the middle. And then the physical is the three elements of earth, water, and fire, those being the three elements that are visible with the senses. And obviously one could say an awful lot more in terms of how they all operate in their function at all levels. But really my question is, in terms of quantum physics, would more be potentially revealed by considering more than just two layers of reality? And Jonathan, just one thing, you mentioned quantum field theory containing all these possibilities. Of course, that reminded me of this causal level.
Mm. We had various conversations at Pari about this, didn't you? And I know infinitesimally what you know about Vedantic philosophy, but I think there's some intriguing thoughts in there. I would certainly wish to include a mental layer in my way of looking at the world, but also I would want to emphasize that for me, they're not layers like you get in lasagna. You know, they fade one into the other. So I just think this is an interesting line of inquiry. I can't really comment on it any further, I'm afraid, because of my limited knowledge of the of Vedantic philosophy. But I've got some books over here which I've been promising to read for a while.
But just to sort of say one thing we did discuss, and it's fun, those discussions with you at Pari were just fantastic. Because you sort of provoke so many thoughts, including unfortunately at 3, 4, 5 o'clock in the morning.
Oh, quite.
I suddenly woke up. But I mean, one was just imagining that in terms of measurement and collapse, for tiny, tiny things, it's totally random because it's fine. But if something was more, you know, important to do with evolution or whatever, it just struck me that this causal level could actually change collapse from being random to being somehow in a direction that is suitable, for example, for the evolution of life. And that's just one thing that I know I sort of possibly thought of at 5 o'clock in the morning based on those conversations, the idea of having a causal level that actually results in collapse not being random when it's something significant, whether it's, you know, the evolution of life or the development of our own human body, whatever.
I know I think in one of our conversations, I mentioned an analogy that I find very intriguing, which is like the book. You know, if you have a well-thumbed book, it often has creases down it. So if you hold the book like that, it falls open in a particular way. And that may be the way the world is. It has creases in it that allows it to fall open in particular ways. But just from time to time, we can pick a different way of opening it.
Brilliant, thank you. Yeah.
Before we jump, may I ask you, Alan, to speculate in relationship to Vedantic philosophy? Because you mentioned, I'm very puzzled by these nor two, not two, nor one, maybe three. And also Bernard's theory contains three worlds, we could say. And our tradition, at least here in Europe, of course, or religious tradition, if I can mention it, Christian, had to do with the Trinity, the idea of three. So it's not one nor two, is a mystery about a play between three that are one at the same time. Can you say something more about that and how both these Eastern and Western views relate, and maybe what they can offer for science?
Well, yes, I mean, I think Advaita, can you actually hear me? Because I've just got a message, my connection's unstable. It's okay, good.
Yes, yes.
Advaita means not two. And so in a sense, yes, it's the philosophy of unity, but it's also the philosophy of, well, multiplicity. It's the underlying reality. But what is intriguing is three comes up within Vedantic philosophy all over the place. So in a sense, at this causal level, in terms of the whole of the creation, it is said that there are three, what might term forces or attributes, which are sattva, rajas, and tamas. And rajas is sort of relates to energy and movement. Sattva, so that's where the movement is. Sattva is stillness and peace. And I think one would, well, it's all consciousness, but one would associate it with consciousness. And then you have tamas, which very wrongly can be regarded as the one that is the sort of negative one, which is not true, but it relates to form and, yes, form. So again, it's still, unfortunately, it also has the connotation of dullness and various other things, but in a positive way, it is actually what gives creation form. And I was just very struck. So this is incredibly ancient, going back thousands of years. And we have the equation E equals mc squared. And it just really struck me that E seems to relate to rajas, the mass seems to relate to tamas, and the C relates to consciousness, light, and sattva is always regarded as light. And even more than that, there's a mantra that is one of the, I guess, incredibly widely used for mantra meditation. And actually, again, it contains the same three elements, representing tamas, sattva, and rajas. And intriguingly, this particular mantra, in terms of its pronunciation, the sattva, or the light syllable, has twice the length of the other two syllables. And I again thought that was extraordinary in terms of in E equals mc squared, the C being squared. And the only other thing I would say is you mentioned the Trinity, but to show how all these things actually tie up, and I don't know if this is true or not, but linking the Trinity back to sort of Vedantic philosophy, I think I was told, well, God the Father is the creator, which in Vedantic philosophy is Brahma, not Brahman, Brahma. If I get, I think that's right. The Son is the Word, which, yeah, as at the beginning of St. John's Gospel, and the word obviously typically is regarded as being Om, which again is three syllables, each one of those syllables representing sattva or rajas or tamas. And then the Holy Ghost is said to be, this is what I heard, is Atman, which is the indwelling self in all of us that is no different to Brahman, or which is which essentially is God, the transcendent, as well as all of creation. So it's just intriguing that we have three all over the place.
Yeah.
And I just think in terms of quantum physics, it would be good just to consider whether that breakdown helps.
Yes. Thank you, Alan.
Thank you.
Do you want to add something, Jonathan, or should we move on?
I couldn't add anything to that. I think it's all
Yeah.
very fascinating.
Yeah. All right. Okay, Gary, please go ahead.
Thank you, Jonathan. Thank you, Alex. I just gave a paper actually this past weekend on semiotic panpsychism, well accepted and by the Semiotic Society of America, but it's a question of, is that, where do you go with that? I mean, I think it's interesting that Colin Wilson, the British author, basically said at one point, imagination should be used not to escape reality, but to create it. I think, that ultimately we are relational beings who happen to have inherited through biological evolution a physical body, and that we've inverted everything, right? I mean, that we've made the assumption that what is primary is what we perceive directly through the senses that have been granted to us by biological evolution, but that the essence is actually relational. And we've, kind of mistaken one for the other, that it is actually substance that is abstract, and relational that is concrete. But I used to be one of those biologists who was, or neurobiologists who was at the red light, right? One of the key issues that comes up is the question of free will. And this is really a concrete, important issue. It is what pulls our society together, whether we can, hold each other responsible for our actions, because ultimately in the beginning was the deed. And I think that's where we need to begin from, is, the primacy of action. And that we are each actors in the world. So one of the questions that comes up is, if we go by the classical world, which is entirely deterministic, right? I mean, there's a Laplacian demon that's going to tell us that everything is going to happen in this way in accordance with physical law. If we know that, the initial conditions, then there is no free will. And there's plenty of biologists out there now, neurobiologists, who are basically saying, free will is illusory, which, that's the natural, a result of assuming that that the brain produces consciousness, right? But I think maybe Jonathan, you could elaborate on this, because this is my question: is what is quantum physics telling us about free will? And I know that Ruth has written a whole article about, Bourne's rule and its relationship to free will, and the idea that free will goes all the way down to the subatomic level. That's not what classical physics would be telling us at all. It would be telling us that we are machines and that we have no free will, and that our lives are entirely predetermined, and that any decision we make has already been predetermined. And so, I think the practical issue here is, do we or do we not have free will?
Yeah, I'd like to make a few comments, if I may. Firstly, I think quantum theory arguably could be regarded as a relational theory, in that when we are describing these possibilities at the implicate layer, if you like, we always seem to be describing a quantum system in terms of what it will become rather than what it actually is. Its isness is what it might become. I'd make that point. The second point is I'd like to slightly take you up on the fact that classical physics says that there is no free will, because one of the things we've never discussed in this context, I don't think, and I think should be brought into this conversation, is chaos theory, which, as I'm sure many of you know, is a very, very badly named theory, in the sense that, according to chaos theory, there are certain things that cannot be predicted at the classical level because they are too very, very finely determined by exactly what the initial conditions are. The weather is the classic example. You've got this butterfly churning up the air somewhere in Guatemala, and it causes a thunderstorm somewhere else. Very famously, Terry Pratchett suggested that rather than spending all this money on research into chaos theory, it would be better to find the butterfly and get it to stop. But I also like very much the work of a chap called John Polkinghorne, very, very great physicist, who then went on to become a priest and eventually became, although I don't think he'd necessarily think that was the culmination of his career, president of Queen's College. And I met John and had many conversations with John. I was very privileged to have a relationship with John. And he believed that the real truth of chaos theory was it was a signal that the laws of nature, even at the classical level, were more supple than purely Newtonian portrayed. So in other words, he felt that there were extended laws of physics still to be discovered at the classical, the explicate layer, never mind the implicate layer. And that his belief was the fact that we see this apparent uncertainty, if I can phrase it that way, in chaos theory is actually a signal that Newtonian laws are only an approximation. And they may well be a good approximation when your system is isolated from everything else. But when it's interconnected with everything, as we know the world ultimately is, then these slightly more, he used this lovely phrase, supple laws of physics come into play. So I'm a great proponent of free will. And I would like to say to the neurologists that try to convince me that there is no free will, why are you trying to convince me? Because anything you say is not going to have any effect. It just happens to be the gears in my brain don't align properly. So just go away and let me enjoy my pint. So I'd like to say that to them. And I can't commend here enough the work of a sadly recently deceased Oxford philosopher called J.R. Lucas, who did an awful lot of work on dismantling the notion of that there was no free will based on Gödel's theorem. And I can't commend his work highly enough. So summary answer, I don't think quantum theory is the answer to free will. I think quantum theory has set the light on green to indicate that we're in a universe which is more than simply the Newtonian. But I think it's interesting to explore what might be happening in chaos theory at the classical level as well.
Those convinced of a deterministic universe will tell you they cannot help but try to convince you about that, right?
Yeah,
they'll be happy with that. They'll be happy with that. And just to add here, because I hear, and it may be fair, some people say, well, if we invoke chaos theory, well, it's as you just said, it's just apparent. Indeterminacy, like practical, but not fundamental. Yeah. But if you invoke quantum, then it's fundamental, but still random. So it seems you cannot get decisions out of this. Well, my solution would be, well, maybe it's not in physics where we're going to find the leading thread to answer those. And we need phenomenology, and we need philosophy, and we need the humanities. It smells a little bit a kind of scientism to go and look for the core or the beginning of these answers always to physics. Like, sure, quantum mechanics is great, but what do artists have to say? What do mystics have to say? what do philosophers have to say about that? And probably their reasons are more powerful than the new theory of physics. But of course, physics has to be, what is it, congruent, coherent with all of that. So in a way, there must be a unity of knowledge. But from, again, I agree, from quantum or from classical chaos theory, it allows for it, but it does, in a way, it doesn't follow from them that we are free if we are.
Yeah. I would just, one very quick comment. I couldn't agree with you more. I think it's just a case of providing a scenario in which it's acceptable for physicists to get involved in the conversation.
Yeah.
John, Alex, can I just add a snippet of a remark in follow-up to what Jonathan said? I suppose it partly just slightly disagreeing. I mean, to me, consciousness itself is not part of classical physics, if by classical physics you mean relativity theory. The normal space-time description does not allow consciousness, it does not allow the passage of time. As I discussed in my talk at Pari, you need to go to at least an extra 5-dimensional picture where you've got mental time. So if you want to have free will is presumably associated with consciousness. So I would say you've got to go beyond classical physics if you want free will, because you have to go beyond classical physics if you want consciousness. Now, I'm not quite clear how that relates to chaos theory, because I was thinking of chaos theory as being something within classical physics, but maybe there's some ambiguity there.
Well, just simply that John Polkinghorne was a believer that the signal that chaos theory had this unpredictability into it was an indication that was something ontologically more supple about the world, and actually chaos theory as it exists now needed to be expanded to include these possibilities as well.
No, I understand that. Somehow it seems a bit strange, though, that my consciousness is associated with chaos. I mean, maybe human beings have inserted chaos into the universe, but
again, my job of badly misrepresenting John, I don't think he would say that chaos implies consciousness. I think again he would say that the world is open. The description of the world is opening up more into one where we can imagine consciousness inhabiting.
Yeah.
Can I just say, I know Todd wants to speak just very quickly, if I may, just on that. It's just a question of what we mean by free will, because I'm struck just about this physical, subtle and causal worlds. I can imagine that there isn't free will in terms of taking the left path versus the right path, in the sense that that's all in creation, and maybe it is mechanical in terms of that. But there still could be free will at the causal level in terms of what one brings into the universe, what one makes manifest in terms of creativity and so forth. So I just think, a starting point would be to define what we even mean by free will and different possibilities. That's all. Thank you.
Yes. Yeah, thank you. Okay, we have about 10 minutes. Todd, you've been patiently waiting. Please go ahead.
Well, first of all, it's good to see everyone, and thank you, Jonathan. To follow a little bit along the line of questioning that Alex proposed, and asking Jonathan to put a speculative hat on and bring it to a contemporary and maybe more depressing level, giving the imprimatur of the Nobel Committee, it's putting these items, entanglements, spooky, etc., more in a forced public way, and also within the community of physicists that many have been content to walk by with eyes averted like a bad accident. Do you think this will materially change people grasping this, both in the depressingly commercial sense, but also more importantly in the theoretical sense, and in essence, essentially, and hopefully in the more esoteric sense? Do you think it will move the needle much by having the imprimatur of the Nobel Committee shining a light on these items?
I think I've got a slightly pessimistic view on it, in that I think, starting up from a different direction, I have a very good friend since school days who's a professor of physics, latterly at Swansea, now at Liverpool University. And he and I have exchanged much correspondence. In particular, he sort of acted like a physics checklist in my quantum reality book. And he did say to me, the problem is, Jonathan, that in meetings of field theorists, which is his particular area, we never discuss these sorts of things, you know, and that is, Bernard would, you know, correct me if I'm wrong, but at the professional level, the working physicist very rarely sits down with their colleagues and discuss what does quantum theory actually mean, unless they happen to be fortunate to be in Anton Zeilinger's group, in which case you're sort of working on it the whole time. I do hope what it might do is raise a bit more public awareness of it. But I do fear, again, I'm sorry to be slightly too bleak on this, that it will raise quantum hype rather than raise reasoned discussion, if I can phrase it that way.
Okay.
I mean, sure, there are conferences that people go to where they discuss the foundations of quantum theory, but in terms of the overall work, the great gamut of work that's being done in physics that uses quantum theory, I don't think it comes up very often. Bernard, am I misrepresenting the community?
No, I don't think so. I mean, it's a purely sociological fact that what you're saying is quite correct. But I suppose the fact that the Nobel Prize has gone to these people will encourage a greater discussion among the physics community of these issues.
Hopefully so. Yeah.
Can I also say, since I've got the floor, I'm so pleased that Alan raised this point about the third component in some sense, and it reminded me of the famous work by Ouspensky, you know, the tertium organum, saying there's a third way which sort of links Aristotle and Bacon. But I have my own take on that, which may not make sense at all. But when one talks about these three levels in quantum theory, it seems to me that there is an analogy between that, in some sense, the physical level is classical relativity. The level of the subtle is the level of quantum. And the third level, what Alan called the causal level, is which is deeper than both of them. So in terms of my Ouroboros, you know, you've got quantum theory on the left, the micro world, relativity theory on the right, the macro world. And it's where they meet at the top of the Ouroboros, that deeper theory, if you like, that's the level of quantum gravity. That is the level of, perhaps, that is the level of what Alan is describing as the causal. But I'm not sure about that, Alan. I mean, I'm only just saying that out of the top of my head, but at least there is the level of three coming in.
Bernard, just very quickly, this is a textbook that I helped write on A-level physics.
Oh, right. Oh, fantastic. Yes, I'm wonderful. It's wonderful it's in there.
And it's in there right at the beginning.
Right. And so right at the top of that Ouroboros, maybe that's where Alan's third world comes in. Does that make sense to you, Alan?
Yeah, yes, it does. As I say, the causal is said to include the unmanifest, an infinite number of universes, and then it's what's brought forth. And that's why it's associated also with the heart and what one brings into creation. So yes, it certainly does.
Oh, that's really nice, because like Jonathan, I have no expertise compared to yours in these ancient texts, but I do think there is important clues in these ancient texts as to the nature of reality.
Let me ask something kind of a derivative on that, which is, given these three worlds, do you think there's a hierarchy amongst them? In the same sense that Ian McGilchrist speaks about the two hemispheres and their importance, but one should be the master and the other one the emissary. So now, Bernard, when you mentioned classical, quantum, and then this third one, it sounded to me like this third one, in a way, embraces and transcends the two previous ones. So is there a hierarchy in these worlds?
Well,
and maybe Alan can...
Shall I just answer in terms of the Vedics? It's quite clear, I think, and that is the physical depends on the subtle, and the subtle depends on the causal. So in terms of the three bodies, and this is where we are said to sort of get it completely wrong, is our physical body is the smallest, the subtle is much larger, and the causal much larger still. And in terms of typical thing is we always think, our soul or whatever is this tiny little point somewhere inside of us. Well, you have to reverse it all. And just if you want something that's just very curious, which I didn't mention, is that one particular sage, and it's intriguing how these sort of these great sages in answering questions, they just slip in something occasionally that just really surprises and wakes you up. And if I remember correctly, I think he made the comment when he said something like, the physical world is made up entirely of departed beings. Now that's an extraordinary thing to say, but again, it has this sense of it arising from a deeper level of reality. And I suppose if one thinks of collapse of the wave function, in a sense, that is something that's departed. But anyway, there we are. So that's they depend on each other with a causal at the top. But having said that, consciousness, transcendent, it's all consciousness, and transcendent is above and beyond, and well, it's transcendent.
Yeah, so, and maybe I can follow up on that remark too. I mean, in my model, it definitely is hierarchical, because, I have this hierarchy of extra dimensions, which corresponds to a hierarchy of consciousness. And so, however, and furthermore, it's not just hierarchy in the sense of three. I mean, Alan talked about three, but in some of these esoteric systems, it's more complicated than that. You have your 7 planes and things in theosophy, and Kabbalah has more. So in some sense, you start off with 3, but then you can always decompose 3 into a more complicated gradation. But on the other hand, I don't think one should think that just because you've got a hierarchy, that means that the top of the hierarchy is more important in some sense, because to me, all these levels of the hierarchy are crucial. As someone said, I think Alan said, consciousness is operating at every level. It's not as though you've only got consciousness at a higher level. Consciousness suffuses the whole picture. And so I don't think one should infer from this that just because the physical plane may be in some sense the lowest plane, that doesn't mean it's unimportant. To me, it's just as important as because presumably no one knows why we're here, why the universe exists, but presumably there's some reason why the physical world exists, and therefore one has to assume that's important. And therefore, I tend to disagree with people who take the view, oh well, the physical world is just an illusion, and what's really important is the spiritual world. I mean, they're all important. That's my perspective, anyway.
I've always assumed that the world was here so that David Lorimer could read books, but I think, if I may, Alex, a related but possibly, I was about to say slightly more interesting question, but I don't want to insult your question, is, all right, there may be a hierarchy of worlds, but can these worlds interconnect with one another? We kind of think that the effect is is going that one way through the hierarchy, but is it possible that it could also go the other way? So can the material level, can the explicate level affect the implicate level? Can the implicate level affect the mental level? Does it go one way, or does it go both ways? And I kind of believe it goes both ways.
Yes. Thank you.
I would say there's evidence for that. Because clearly what happens in our mind is affected by what happens to our body, and what happens to the body is affected by what happens to the mind. So I would agree with Jonathan.
Now we went an hour and a half, but I see two hands raised. So if you need to leave, please feel free to. But let's talk for 10 more minutes, if you may. Well, now one hand was off, but Todd, you can come back later. Yes, Hugh, please go ahead, and then Todd, if you still want to ask, let's wrap it up with your question. Sorry, you need to be unmuted. Can you unmute? Yes.
Thank you all. I'm sitting in a state of considerable humility in the face of that extraordinary exchange, and I wanted to take the opportunity just before we close, reading one sentence, given Alan your reference to Sattva, that I have in front of me a book which has a beautiful title, Sitting in the Stillness. and its subtitle is Freedom from the Personal Story. It's an examination of how we get entangled by our own stories. But the sentence I wanted to read is a tribute that will actually go in the reconstructed final version of Beyond Words, the film. It's a tribute that I'd like to offer those of you who've been contributing to this conversation, because I'm in awe of it. Here's the sentence. Thanks to the poets and mystics quoted in the book for finding the words to describe what for most of us is beyond words.
Wow. Thank you. Thank you.
This is actually a really good way to end this conversation. But Jonathan wants to say something. Yes, go ahead.
We've only heard from the blokes. We've not had a single comment from one of the ladies amongst us. I mean, are they still there? In fact, all I can see on my monitor actually is a row of white male faces.
Ladies are beyond words, perhaps, Jonathan.
Yeah, possibly. We're that bad, are we, Bernard, that we are beyond description?
Brigitte, I think you're speaking, but you need to unmute yourself too. Yes, here.
One moment.
Yeah.
Can you hear me now?
Yes.
Can you hear me? Okay. So another female voice. Just to mention, I'm really overwhelmed. It was so interesting for me, even though I can't contribute to all the theoretical aspects you brought up. So often I feel myself in, yeah, I know that. I know that from the practice. I know that from Qigong. And I can only, if Ellen talks about the Vedantic philosophy, I can only encourage you to read the basics of the I Ching, to read the basics of the Taoist philosophy. You find all that in the cosmogony, sorry, my English, of the Chinese philosophy. And it is very, very special for me was the image of the cross of the axis, the actuality and the axis of possibility. We work with that in Qigong every day. So I try to embody these axes inside my practice. I try to embody the Trinity, the physical body, the subtle body, the causal body in my practice. That's everyday life for me. And I'm so very touched by hearing all the theoretical explications of what I'm doing. So I feel understood. I feel very grateful. And I'm looking forward to the recording, actually, because it was so dense for me that I have to review the details you brought in. Thank you, everybody. Thank you, Jonathan. Thank you, Alex.
I think, Alex, we're developing a theme for another Pari conference here, aren't we?
Yeah, absolutely.
Yes, very important. The note about embodying what we're talking about.
The only other thing I would just very quickly add in my defense, if that's the right word, this computer is currently resting on a copy of Shantana's Tao Te Ching. If it's just sitting on,
this is both the best and the worst possible use you can give to a book.
Yeah,
you know?
Absolutely. This is my desk, but my table wasn't quite high enough, and that was the nearest book of sufficient.
Well, actually, mine is laying on your book now.
Well, that's probably all it's worth. My books. That's very nice.
All right. Anybody else wants to add up something before we really finish for today? No? All right. Well, it's been delightful. Thank you so much for your presence, and more soon.
Thank you for organizing this. And take seriously what I just said about here we've got a hint of a new Pari conference to do with Vedana and quantum theory, maybe, or Vedana and physics.
Yes, definitely.
And the practice of Qigong.
and the practice. I'd love to have an experiential aspect to it.
Yes, I would love that.
All right, let's leave it here. Thank you.
Thank you. Thank you again, Jonathan and Alex.
Yeah, thank you, Alex, for setting all this up.
My pleasure. Awesome.
Thank you, Alex. My goodness. Oh, my word. Thank you.
All right. Thank you, everybody.
Thank you.
Community. Bye. Ciao.
Thank
Jonathan,
you.
Take care. Good morning.